Hi everyone, this is Stefana Muller and Peter Nicola from Opsani. Today we're going to show you how Skopos can help accelerate your move from traditional apps to Docker. Ready, Peter?
Ready. So if your company is like others who are moving their existing applications to containers, you've already done some of the work. Some of your engineers have been experimenting with containers, building containers for your application, usually combining them the same way as they build them in virtual machines or physical servers today. So when you decide that, okay, this is wonderful, they were manually deployed, they kind of got it done to work, but now it's time to put it all together and make it repeatable so that you can take the advantages of acceleration. So the starting point usually is you have those containers running. So if you just look at the developer's laptop or the cluster that you set up, the Docker Swarm cluster you set up, you have a bunch of containers that are up and running, and you need to make sense out of it. So the first step is to look and find out what it was actually deployed. At the end of that experimentation, what is running, what comprises, what are the services that you ended up with. So in Skopos, we have the surveyor, which allows you to discover existing applications, and we use some heuristics to associate containers that work together into application stacks. So this is what Skopos is discovering now. It found 3 different applications. The one that we will be interested in and we'll go over today will be the demo application. As you see, it consists, this is the Skopos visual editor that shows you what is the architecture of your application, and for each of the services, you have a block, and then for the gateways, you have a little cloud that connects you to the internet. So you will see our current application has 2 different services. We'll switch here to deploy mode, and you can see its status. The backend service, which probably contains most of the functionality of your app, has 3 replicas. It is version 1.0, and the front end, which let's say is called both, has just 1 instance. So the first thing that you see here is, hey, there is something wrong. That little orange dot here indicates that something is wrong. So let's go and check the status of the Vote app service. If you click on it, you will notice here a very quick summary of what that service is. You see the image that it deployed, number of replicas, and what ports it exposes. And you'll see here is there's the status link, which if you click on it, it will show you the status of that service. And you will notice on the left side, there's the list of instances. It has actually 2 running instances, and one of them seems to be in good shape. The other one seems to have an error, but let's first look at what is there for the running one. So we have the instance ID of the container, which is how you can find it back in Docker, the image version, the IP address under which you can find it, and that it's running okay. You can also see some statistics, CPU use, memory, network, and disk, as well as you can see what are the processes that are running inside. You can also click on the logs and see any log messages, errors that were displayed by the service. So let's look at the second service, or second instance of that service, and you will see that it actually is not running. It had some error, so it was just left this way from whoever was playing with it. So there's a common error that happens when somebody tries to manually deploy over a service that already exists, and it uses a port number. So we'll get out of here and then take another look at your application. Consists of application stack consisting of these 2 services. What you would want to do in order to make that service deployment repeatable, so that you can keep using it not with manual deploy, but in an automated deploy, is to first see, hey, let's see if we can get a compose file for it. And here, by clicking on the descriptors of compose file, you get the compose file that we created based on the components, the services that we discovered. So here's the back service with its image and deploy parameters, and the front end Vote service with those parameters. So this is good to go. If you just save this as your compose file and run it with Docker Compose or with Docker Stack Deploy, it will deploy. However, again, if your application is like most traditional applications, it wasn't developed like a 12-factor app. Those 2 services are not independent. And the first thing that that means is that the backend service has to be running before the front-end service starts. Otherwise, the front-end service will fail. So with Skopos, there is a way to make that happen, to make sure that the backend service is up and running properly before the front-end service is started. So we'll switch to edit mode, and now we will modify this service graph that we're creating here. In Skopos, it's called a model, but it essentially contains the services and their relationships. So we are saying, you know, the vote, which is the front-end service, depends on the back-end service. It talks to it, and it needs to have relationship, dependency relationship with it. And once you select that relationship, you can even define what is the start order requirement. Is it strict, which means back must be running before the front end starts, or it can be tolerant, which means they can start together, or they're completely independent. So you have the ability to control that. Another thing that frequently happens as a need, as a requirement to traditional applications that are being moved to containers, is to be able to do some additional actions, whether they're configuration or registering the container instances or their IP addresses with another system. Usually that would be like a CMDB system or a monitoring system. And again, there is no normal standard way to do that. And Docker provides these additional steps. So you can select the backend service and then click the edit button for that service. And here, again, you will look and see the common parameters for that, the name of the service, the image, version tag, number of replicas. And then you can go to the lifecycle section, and I have prepared a set of steps that need to be executed for this particular backend service. We're not going to go in much detail here, but the main thing is we have added a quality probe that will serve as a readiness indicator and verify that the backend service is actually functioning and providing its service in its API before we even allow it to continue with deployment of the front-end service. And then we have additional steps that need to be executed after the component and instance is deployed or when an instance is taken down. In our particular demo today, we're just going to send a message to Slack with the IP address, but you can easily see how this can go to things like SolarWinds for monitoring, CMDB system, firewalls to enable and disable. So these are, again, things that are typically needed by traditional applications. So the next step for our application is to separate the database from the backend service. In many apps that are running on VMs or on physical servers, the database engine is part of the backend. But as you're moving to containers, you do want to separate the components into separate services. So with Skopos, this is very easy. What we want to do is add the database container to our application. As a new service. So you click the add button, and here you see a catalog of the most frequently used Docker Hub images. So in this particular case, we are going to select the MySQL database server and add it to our application stack. Because, again, this is a traditional application, so the backend service actually cannot start until the database engine is running. So we will create another dependency saying backend service uses the MySQL service, and we will define a strict start order. So we make sure that MySQL is up and running before the backend starts. And then we can go in the MySQL properties, define it as a stateful component, and you see a little disk icon showed up indicating that it's persistent. And for MySQL, we also need to add a couple of environment variables to configure it so that it will start correctly. So we go to the property sheet, environment variables, add the MySQL allow empty password property, and set that to yes. This is also if you have additional parameters, like let's say the root password, if you prefer to use a more secure way in production, you can add more environment variables. You can define volumes for persistence, ports, labels, and other attributes. So we're done now, and we save it. And now we are done with the changes that we wanted to make, and we can save the stack. And now we see our service looks like what we want it to be, and it is ready to be deployed. So we see the MySQL that we just added. It is a stateful service that has persistence, which is why it has the little disk icon here. The backend service, to which we added additional steps to connect to an existing management system, and the vault service, which needs to be repaired because it had two instances, one of them was not running. Before we continue, now that we have modified the service graph, we can look at this and again get the compose file for it, and get the new service. As you see, the new service here, the MySQL service is also visible. And if we didn't have dependencies or additional steps, we would be able to use the compose file directly. However, in order to take care of the dependencies, we will use Skopos deploy. So before we actually start the deploy, let's see if we can get a little bit more information about how Skopos is going to deploy. So if we go to the switch to plan view, we will see the same application now shown in the what we call the automatically generated deployment plan. You see that there are a number of steps, and that the sequence here follows the dependencies that we created. So the database engine is going to start first. Once it's fully started, then the backend service will start, and then the front-end code service will start. So let's take a look at one of these. Let's say the MySQL service, and you see there are some standard steps. If a step fails, we go through rollback and cleanup so that the app will remain running. You also see that there is a quality gate here that will make sure that the service is up and running before it allows the backend service to start. And then looking through the backend service plan, there's a lot more steps, as you see. Again, because this is a traditional application, we included in the plan the additional steps that we manually specified a few minutes ago. So we can look at the authorized new IP address, which is the connection to an external system. In this particular case, again, we're sending this information to Slack, as well as we added the quality gate that will verify the service is up and running. So without much ado, we like that sequence. We're saying, hey, this is good. We are now confident that this is how we want the application to be deployed, and let's start it. So you see Skopos is reflecting on the screen what is going on. Right now we are waiting for the verification of the database engine to be up and running. As soon as that is done, we start deploying the backend instances. And we can pause this. At any time, you can stop and say, hey, let me just look and make sure that everything is going on fine. You can switch, you can go to Docker, check logs and anything else that you like. You can even go step by step if you want to make sure that you understand what is going on. And then once you're happy, you can just click resume and let Skopos finish the deployment.
Hey, Peter, could you talk a little bit more about the containerized application probes and how they're different from health checks?
Excellent, thank you. Yes, so we do use the existing health check services that are included in the container specification, but on top of this, we add support for what we call containerized application probes. So we run readiness checks and health checks as containers, and so you can specify and add steps that are a lot more detailed and much more deeper verification, so that they can include actually checking database parameters or API requests in a deep way. And those are the probes that we see here with that little yellow sign.
Great, thanks.
Sure. So now this service was deployed. We can switch back to the model view, see that everything is running fine. We can take a look at MySQL, which is the new component we deployed, and even check its logs. A lot more interesting than the previous logs I showed. So you can see what has gone on, as well as you can also get the detailed status and statistics. You see, let's say that MySQL has used 186 megabytes of RAM. We have this application, this set of services ready to be deployed in a reliable and repeatable way. You can get the compose file, And as you see, it also includes the Skopos extensions so that you can load it again. If you can also use the Skopos Autopilot, which allows you to automatically deploy new instances, new versions as soon as they become available. So kind of completes the CI/CD chain, or you can just use our command line tools or APIs to make that a part of your workflow. And another thing that we would like to check is, if you remember, we added some steps in the backend service to tie it to an existing management system. Again, in this case, sending the information to Slack. So let's go and check that. You will see that during the deployment, Skopos sent notifications to Slack about each of the instances of the backend service, providing their IP address, container ID, things that would be sufficient to add them to firewalls, CMDBs, monitoring systems, and any kind of backend management systems that you need.
So if we were to use the APIs, you could probably tag it into whatever CI tool you're using to make the deploy happen, correct?
Correct. We have integrations with Jenkins, with other CI/CD tools, and it is very straightforward. There's a command line utility that makes it really easy to run new commands. So everything that we did here through the user interface can be done through the CLI, and we also have an API through which you can send these requests if you have a programmatic API that needs REST.
Great. Well, thank you, Peter. I think we went through a bunch of features that you had mentioned that will help people move from their traditional applications over to Docker.
Thank you, Stefana.